So my name is Rianne, and I'm here to talk about generating missing data. So first, let me ask, who of you has experienced missing data? And who of you has generated missing data? Ah, that's quite some. Nice. Of course, you're not happy with your missing data, so why would you want to make it? The reason I make it is because I am doing work on missing data methods. I do research like what missing data methods are good and when should we use them and when should we not use them. So that's the simulation purposes at the top. But for all of you who are not missing data methodologists, generating missing data might still be useful. For example, to see what kind of missing data is there in my data, what effect does it have on my analysis. So also for you guys, this talk might be useful. And then for all of you who are never going to generate missing data, I'm trying in this talk to also address like characteristics of missing data. And by doing that, I hope that this talk is also useful for the ones of you who have to deal with it and are not going to generate it. So let's say we have a data set, 3 columns, missing data in 2 columns. And then there is this package in R, which is called mice, and it has the function md.pattern. And that is the first thing you can do if you want to investigate your missing data. It tells you what kind of patterns you have. And with a pattern, what we mean is a combination of missingness on variables and complete variables. So for example, this is a pattern. 412 rows have a complete value on age and income and a missing value on working years. 200 rows, 206, have no missing values. And by having this overview, you can already find the reasons for your missing data. For example, you perform a questionnaire, and there are a lot of rows with missing values on questions 20 to 25. And that's one pattern that you see. And then you think, what might be the reason for this missingness? And then you discover that questions 20 till 25 are on the back page of your questionnaire. And a lot of people forget to fill in that page. This is, of course, a stupid example, but it shows that having these patterns helps to find the reasons for your missingness. What if we want to reproduce these missingness? What if we want to recreate this kind of missingness in a simulated or in a fake data set, or even in part of your data set that is complete? So until recently, what happened is that people generated missingness in one variable, let's say y1. That's easy to do. You have these functions in R called rbinom, or generate a random number between 0 and 1, and use that random number to generate missingness. And then if you want to create missingness in a second variable, you repeat the procedure for y2, and so on for all the variables that you want to make incomplete. By following this approach, you have missing data in your data set, but you have no control about the characteristics of the missing data. You can't control the proportion. Approximately, you can, but you don't know exactly which rows are going to have an overlap between y1 and y2, and how many rows are going to have missingness on 3 columns or even more. So you want to control those kind of aspects when you are generating missing data. So what we did is we developed a multivariate procedure. This is the procedure. It might look complicated. It is not. It's really easy. If you want to read and understand the method, we published this article, and there you can read all about it. But what we also did is we implemented the method into an R function, and that R function is called Ampute, and it is in package mice, so the package I mentioned earlier. So the basic idea of the function Ampute is this argument, patterns. In the argument patterns, you specify what kind of missing data patterns you want to create in your data set. This patterns argument always have to be filled in as a matrix, where the amount of columns equals the amount of columns in your data set, and then each row is a pattern. You can add as many rows as you want. We use a 0 for the variable that needs to be incomplete. So in this case, we want to generate three patterns, and then this is the outcome of the function. What you see is that we have 500 rows that have no missing values. That is what we specified here in the proportion argument. So proportion is 0.5. It means 50% of the rows should be incomplete, 50% of the rows should be complete. Then of those other 50%, we see this 300 rows that have a missing value on working years. No missing value on the first two, on income and age. So actually that is the first pattern here. Remember that earlier I showed the data set and working years was the second column. So that is how we specified it here. Working years is the second, age is the third, and that corresponds to this pattern. And then the last two patterns are these two here in the result. Now you can use the frequency argument to specify how often a pattern should occur. So 60% of the incomplete rows should have missingness according pattern 1. And that is exactly these 300 rows. And then 20% of the incomplete rows should have missingness according pattern 2. And then the same for pattern 3. So this is the basic idea of the function. Then another thing that is very important when you generate missing data is the mechanism. In this case, we specified mechanism is MAR. Let me ask you, who of you have heard about missing data mechanisms? Okay. Let me talk a bit about missing data mechanisms. First of all, so it is in package mice, the function Ampute, and it has much more arguments. And an explanation of all the things that you can do with it is in the vignette that you can see, that you can find here. So missing data mechanisms, we consider 3 mechanisms. One is missing completely at random. And that is missingness that is not related to any variable. So for example, the probability that some value on variable income is missing is 0.5. It is fixed. It's a fixed probability. Then we have missingness at random. Then the missingness is related to an observed variable. The missingness on income depends on the value on age. And you could say people with a high age have a higher probability to be missing on income because they forget what their income is or something. Any reason. And then we have the third mechanism, and that is missingness not at random. Then the probability to be missing on income depends on income itself. And it is very important to think about this mechanism because it helps in solving your missing data problem. In this case, if you have the variable age completely observed, you can use the information in age to refer back about the missingness that is in income. But in this case, if you don't have the missing values and the information about the missingness is in the missing values, then you have a bigger problem. So that's why these 3 mechanisms are important, and that's why it's important that you are able to create them with the function Ampute. These are visualizations of the fact, so of the same thing. So missingness on income, it's a fixed number, so some high values of income will be missing, some low values. And not that much happens with the multivariate relationship between income and age. But then if you say high values of age have a higher probability to be missing on income, then this part of the data gets missing, and you see that it disturbs the multivariate relationship between the 2 variables. And then you have this situation, missingness on income depends on income. You see that the multivariate relationship between these 2 variables is not disturbed. But you should remember that there are always more variables in your data set, and those relationships can be disturbed. 46 seconds. Okay, then I will close it here. So find the information in the vignette. Email me if you have questions, if you have problems. And also, if you want to know more about imputation or missing data methods, you can always approach me. Thank you very much.